Hello, welcome to this tutorial which will show you how to interface a LED using Arduino digital pins in Proteus. Here is the Proteus simulation environment. In order to proceed, we are going to pick the various components by clicking on component mode, then on pick device to access the library. Then we are going to search the various components, Arduino Uno, double click on it. Then the LED, take note that the LED used here is animated LED. We are going to use the animated LED and you can select any color. We have selected the green color. Then lastly, the resistor. So after selecting or picking these various components in the library, we are going to place them in the workspace simply by clicking on the device or the component and clicking in the workspace. Do same for the other components, the resistor, the LED. Then we require the ground. The ground is found under terminal mode. Click on terminal mode, then click on the ground and click in the workspace to place the ground. Then proceed by connecting the various components. So after connecting the various components, the circuit is okay. Then if you simulate, you are going to receive a fatal simulation error due to the fact that there is no code loaded in the microcontroller. So when you double click on it, you're going to see there is no code. So we are going to proceed in order to write or compile the code using the Arduino interface development environment. Here we notice that we have two functions, the void setup function and the void loop function. Here we are going to use the void setup function and our code should enter within the parentheses. In our next videos, we are going to look how to use the loop function. And take note that your code should enter between the parentheses, the open brackets and the close brackets or parentheses. A double slash here is simply signifies a comment. Anything coming behind the double slash is a comment. So looking at our circuit, we are going to see that the LED is connected to pin 7 of our Arduino, and the LED normally is an output. So the first thing is to configure in the code the pin number 7 as an output pin. So use the command pin mode in bracket the pin number in bracket the pin number, which is pin number 7, then output, and each code ends with a semicolon. So we have configured the pin as an output to which the LED is connected. Then after doing this, we are now going to attribute a high state to that pin in order to turn on the LED. And that pin is a digital pin, so we're going to use the command digital write in bracket the pin number, then a high state. In electronics, a high state signifies 5 volt. So the microcontroller is going to attribute a 5 volt at the output of that pin, which is enough to turn on the LED. So after writing this code, we are going to compile by clicking on verify. It's done compilating. As you can see, in order to load this code in the microcontroller, we need the hex file which has been generated. To locate the hex file, scroll to the right. You're going to see the directory to which the hex file has been saved with the terminal.hex. So here is it. The root directory here is from here. up till the dot hex. So we are going to copy this and paste in the microcontroller or load it in the microcontroller. Take note that you copy from C without the quotes. It is stored in C, users, the I, app data, local, temp, Arduino build 641909, then turning on LED code.hex. So that's the root directory. So we can copy this by pressing Ctrl C on our keyboard. Then you double click now on the microcontroller and you paste. This is one way to load the hex file in the Arduino. The other method is by clicking. Let's consider that we hadn't used this other method. I'll show you how to load the code using this other method. Double click on the microcontroller, click on the folder at program file to select the root directory. Goes to the root directory, C, the users, the I, app data, local, temp, Arduino build 64190. Then this is the hex file. I double click on it, it has been loaded. So in either ways, you can load the hex file. Okay. After doing so, we simulate. You see that the LED has not been turned on or is not shining, but the terminal of a microcontroller at pin 7 is showing a high state, which is red, signifying a high state. This is so because the value of this resistor is very high, limiting the amount of current flowing to the LED. So for this LED to shine, we are going to calculate the value of the resistance, the value of the resistor. It is essential to note that a LED is driven by current. So the LED has a capability of drawing the current which the source produces, even much more than what it requires to turn on, and so the LED can be destroyed. So a limiting resistor is very, very much essential to limit the amount of current flowing to the LED. Then our pin number 7 gives out a 5 volt, which is represented here as V out from our program or from our code, which we attributed a high state at this pin. Then there will be a voltage drop across the resistor and the voltage drop across the diode. So in order to calculate this resistance, we can apply Kirchhoff voltage law to come out with a loop equation represented by the output voltage minus the voltage drop across the resistor, which is I times the resistance, then minus the voltage drop across the diode, which is equal to 0. Because Kirchhoff voltage law states that the sum of voltages in the loop is equal to 0, or the total voltage in the loop is equal to 0. Then we are going to make arrow the subject of the formula, which is given as such. But one thing we don't have here is the current and the voltage drop across the diode. This can be given or can be seen at the data sheet of the LED. So this is the data sheet of the LED showing the various characteristics of the LED with respect to their semiconductor material and the color of the LED. The color of the LED here is very important because the voltage drop across each LED, each color is different from the other. But the current needed in order to turn on the LED is the same or constant, which is 20 milliampere. So you can use this data sheet for the LED characteristics. Then inputting it in our equation give us the value of the resistance, because green here has a voltage drop of 3.5 volts and the current here is 20 milliampere, which is 20 times 10 to the negative 3. So this gives us the resistor. This gives the resistance of 75 ohm. So we have seen how to calculate the value of the resistance. So we are going to proceed to change the resistor value in Proteus. But before doing that, subscribe to this video, subscribe to this channel if you haven't followed this channel in order to receive our notifications and in order to remain updated. So stopping the simulation and changing the value of the resistor to 75 ohm from the 10 kilo ohm, change it to 75 ohm, then simulate. So you see the LED is shining with the green color. So this is how you can turn on a LED using Proteus and the Arduino interface development environment. If we want to modify the code in order for the LED to come on and be turned off, then turn on back again, we can simply give a delay command of probably 1 second by giving this command delay in bracket 1000. Here is in milliseconds. That means 1000 milliseconds, which is 1 second. Then we write a low state at the pin number 7. Then we can delay again and turn it on by giving a high state at the pin, which is digital write in bracket pin 7 high. So if we simulate or we compile this, it's done compiling, we can go back to our Proteus and stop the simulation and run it. You see it comes on, goes off, then comes back again. So this is how you can actually interface a LED using Arduino. Thank you. Don't forget to like and subscribe to this channel in order to receive notification and update from us. You can as well visit our website at ektechnologies.com, where we publish contents, articles, and projects that can be of great help and importance to you. You can leave your feedback at the comment section.